Okay, this video is going to cover section 2.3, which is pretty much about basic limit laws. And these are things that should make pretty intuitive sense. So I'm going to just do this and have a couple of examples, and we'll start with section 2.4 on Wednesday. So the first idea is that we're starting with assuming that two limits exist. The limit is x approaches c of f of x, and the limit is x approaches c of g of x. So we have two functions, and at x equals c, we know that the limit exists for both of those two functions. So we're going to talk about four laws and how those things work. So the first one is the sum law, and it says assuming the limits exist, the limit of f of x plus g of x, that function there, you can find its limit by just taking the limit of f of x plus the limit of g of x. So you can kind of split it into two limits to find the limit for those guys. So this is as x approaches c, of course. Here is also as x approaches c, and this is also x approaches c. So you can split it into two limits for that one. The constant multiple law, so this is the sum law. The constant multiple law says if we have the limit as x approaches c of some k times f of x, that we can take that k outside of the limit. That's the same as k, limit as x approaches c of f of x. And that actually really just comes from this first law, because if you think about k f of x, that means you have k f of x's. So f of x plus f of x plus f of x plus f of x so many times. So that's really the same thing as this first sum law, but just applied multiple times. The next one is the product law. So that one is the limit as x approaches c of f of x times g of x. So if you want to multiply two functions and take their limit, you can do that by splitting it into two limits, the first one, and then times the limit of the second one. So that's the product law. And last but not least is the quotient law, and that's if you want to take the limit of f of x divided by g of x. And in that case, you do the limit as x approaches c of f of x, and then you take that whole thing and you divide it by the limit as x approaches c of g of x. So, and that's all assuming that that limit is not 0. So up here, I guess you might want to say that this limit as x approaches c of g of x is not 0 for the quotient law. Right? Because if it's 0, then you would be dividing by 0, and that would be a problem. So eliminate that situation, otherwise this is correct. So these are our four laws: the sum law, the constant multiple law, the product law, and the quotient law. And it's really just coming from thinking about what each of these limits mean. And if you multiply the functions first, that's the same as taking the limit of each one and multiplying them. And hopefully that would make sense if you think about what each of these things does. So now we're going to look at some examples of how to use these four laws and practice using the laws. So here we're given that the limit as x approaches a of some function is -3, x approaches a of some other function g is 0, and x approaches a, the limit of h is 8. We want to find these different limits. So these are really just applying the limit laws. This one, right, and this means you can split this into two pieces. So x approaches a of f and x approaches a of h. And we have values for each of those. The first one is -3. The second one is 8, so we get a grand total of 5. So we used this one and this one. So that's really all these problems are, is just applying these particular numbers into our particular equations. So this one here would be a limit as x approaches a of g of x, and then we're going to divide by the limit as x approaches a of f of x. And in this situation, that would be 0 divided by -3, which is in fact 0. We'll do letter h down here. And that's the limit as x approaches a of 2 times f of x. So this is 2 times the limit as x approaches a of f of x. And then divide that by the limit as x approaches a of h of x minus the limit as x approaches a of f of x. So it's just splitting everything up into little pieces. We're going to plug all these numbers in. This is 2 times a -3 over 8 minus a negative 3, and so you get negative 5 over 11. Negative 6, I guess. 2 times 3 is 6. And then there's one more over here. The limit as x approaches a of f of x divided by g of x. And in this case, we get the limit as x approaches a of f of x, and then divided by the limit as x approaches a of g of x. And in this case, you get negative 3 over 0. But we know that that's actually not a real number. So here it would be, I think, and remember the limit laws only apply if we actually know where these things go. So here I would just make a note, not possible. We would need some further information. We need to check some things out. It's probably not going to exist because you're dividing by a 0, but you'd want to know, is it going to infinity? Is it going to negative infinity? Is it going to both? And so we really don't know exactly what this thing is doing here. We do know we get an undefined because we're getting a 0 in the denominator, and that's questionable. So we can't actually find this one because we don't know for sure what that limit's going to be. There's a great question down here at the bottom that we'll explore a little bit in class probably this week with a lab worksheet. But what happens if these limits don't exist? So if we have a limit that doesn't exist for f and a limit that doesn't exist for g, and we add the two functions together, is it possible that the addition of those two could exist? And if you look at our description of these limits, it doesn't prevent us from having that as a possibility, because all the limit laws, if you remember on the previous page, the way that these work is that we know the limits exist. So the interesting question is, what if these limits don't exist? Could it be possible that the limit of an addition or multiplication or division did exist? And we'll explore that a little bit in class.